This is the Unit 2, Segments, Lines, and Angles. Preview video 2.2, Segments on a Coordinate Plane. Take a moment, ready, inhale. Hold your breath. Birthday candle. Stretch those shoulders a little. Don't forget a date, time, and location, as well as a parental sign-off, friends. All right, on this page, go ahead, do this on your own, restart the video when you're done. Pause. Get out your red pens, folks. Root 7 times root 7 is 7. 5 times 7, 35. Root 3 times root 3 is 3. 6 times 3, 18. Root 5 times root 5 is 5. 12 times 5, 60. Root 2 times root 2 is 2. 3 times 2, 6. Here I need a root 6. That gets me 6. And the complete answer is 2 root 6. I need a root 5. That gets me 5. Complete answer is 6 root 5. We're going to talk specifically about segments on a coordinate plane. When we say coordinate plane, what we mean is an XY grid. We're going to be talking about rise and run. That should sound familiar. Slope, midpoint, distance, the concept of average. Coordinate plane, and working on a coordinate plane impacts a lot of different professions and scientific studies. There are many professions and situations, including archaeology, stats, cartography, anything that uses, honestly, a GPS system. All of that involves motion on a coordinate plane. We're going to be working with 3 things regarding segments, 3 things. We're going to be talking, if you put your hand like this, trace your arm. We're going to be talking about the middle of a segment. Tilt your arm back and forth, the tilt of a segment. Trace the length of a segment, the middle, the tilt, and the length. I want you to find the middle of the segment between S at -8 and T at 2. We're going to find the middle of the segment. If you bunny hop that, that's 10 units, which means if you go 5 back, the middle coordinate, of course, is -3. We're going to call that M. Now, I'd like you to take the two numbers, -8 and the +2, and average them, which means you're going to add, and in this case, you're dividing by 2 because we only have two numbers. And note, if you average, -6 divided by 2 is at 3. So this is a number line, and we just figured out to find the middle is the average. The middle is the average. The average of the two coordinates is also the coordinate of the midpoint. Since on a number line, you're only dealing with length, you're only dealing with one dimension, therefore you only have to average one time. We averaged one time between -8, +2, we got our midpoint, and that's because this is in the first dimension only. But on a coordinate plane, you have two dimensions. You have your horizontal and you have your vertical. So to find the midpoint, when you have a segment on a coordinate plane, and I want to find that exact middle, because on a coordinate grid, you have two dimensions. To find that midpoint, you have to average twice. When using the midpoint equation, you're going to do three things. You say the equation, you write the equation, you write a blank template, and then you do what's called circle plug check. We're going to say the equation and write it at the same time. And the reason why we say and write at the same time, it helps reinforce because you must memorize this. So we're going to say this. Let me just say it. You're going to read, add the x's, divide by 2, add the y's, divide by 2. Midpoint formula is add the x's, divide by 2, add the y's, divide by 2. Midpoint formula is, let's say it and write it at the same time. The midpoint formula is add the x's, divide by 2, comma, add the y's, divide by 2. The midpoint formula is add the x's, divide by 2, add the y's, divide by 2. The midpoint formula is add the x's, divide by 2, add the y's, divide by 2. So let's do this one together, and then you'll do one on your own. Let's find our coordinates. Our coordinates for this point is -5, +3. You can see that's this point right here. And then we have 1, comma, -5. We're going to find the midpoint. Now a template. What is the difference between a template and an equation? This is your equation with the x's and the y in it. That is the equation. That is the midpoint equation. A template looks like this. It's like a blank equation minus the x and y's. So here is your template. Add, divide by 2, comma, add, divide by 2. Always write a template of the equations before you use it. Now we add the x's. We're going to circle them. We're going to plunk them in right here. Box our y's. Go ahead and do the math. What's really nice is once you calculate the midpoint, if you graph it, -2, -1, it actually looks like the midpoint. The way we demonstrate that is we put these little hatch marks on either side. So add the x's, divide by 2, add the y's, divide by 2. I like you to do this page on your own. Pause the video. Welcome back. Let's see how you did. So you have the endpoint, -3, +8. -1, +5. And we're going to find the midpoint. Ready? Add the x's. Divide by 2. Add the y's. Divide by 2. This is, of course, -4/2, which means your first coordinate is -2. This is 13/2. You're like, wait a minute, that's not even. I must be wrong. No, you weren't wrong. I deliberately did this using a fraction. 2 goes in there 6 times with 1 left over, so it's 6.5. If you come over here, watch carefully. That's -2, 6.5. So over 2. And up 6. 1, 2, 3, 4, 5, 6.5. Looky there, friends. -2, 6.5. It looks like the exact middle, which it is. Fractions are okay. Get comfortable with those. So that's midpoint. You add, divide by 2, add, divide by 2. Now we're going to do tilt of a line. You're using the slope formula. You're going to say, write a template, circle box, plug, chug. So it goes like this. The slope formula is, slope is rise over run, subtract the y's over, subtract the x's. It goes like this. Slope is rise over run, rise, subtract the y's, run, subtract the x's. Slope is rise over run, rise, subtract the y's, run, subtract the x's. Slope is rise over run, rise, subtract the y's over run, subtract the x's. Now, some of you may have learned the equation, of course, like this. y2 minus y1 over x2 minus x1. There is a technicality. Yes, of course, that's correct. But some students get a little bit hesitant because they're like, well, which one's 1, which one's 2? And they get a little kind of wrapped up. I'll tell you a secret. It doesn't matter which one's 1 and which one's 2. I'll show you what does matter in just a moment. Okay, so if I want to find the tilt of this line, we're going to do it algebraically and then we're going to do it mechanically. So first off, I have this coordinate, -5, 3, down here, same points. I start by writing a template. Template looks like this. That's your slope template. Now, this is where students get hung up. Do I go left to right, or do I go right to left? It doesn't matter. What does matter is whatever direction you start with, you finish. So I'm going to go like this. Y's go on top because rise with y's. I'm going to go left to right. 3, -5. And then I'm going to go left to right again. -5, 1. Now, if I go like this, left to right, y's, and then right to left, x's, that would be wrong. Whatever direction you start with is the direction you finish. Y minus y over x minus x. Ready? So I am getting -8 over 6, and if you reduce, that's -4/3. There's my slope. Slope is always a fraction, always, always. Slope is always a fraction. And we would expect negative because it is a negative line. Now, let's test this mechanically. Let's find 2 points of intersection. There's one there. There's one here. And let's check. Our rise is 4. Our run is 3. And we have a negative tilting line, which means that's negative. So it checks out mechanically. Good job. You do these two on your own. Pause the video. Welcome back. Let's first plot our points here. So we write our template. Y minus y, because it's rise over run. So y's go with y, run goes with x's. So left to right, 8 minus 5, left to right again, -3 minus 1. 8 minus 5, that's 3. Double negative makes a positive. Going to be -2, which is exactly what we expect because it's a negative line. So our rise is 3, our run is 2, and it's a negative line. So check, I know I'm correct. These 2 points, Let's find the slope. We're going to write a template. Y minus y over x minus x. That reduces to negative 2/3. Negative, that's a good sign because it tilts downward from left to right. And let's check the slope here. Our rise is 2 and our run is 3. And looky there, it fits just perfectly. It's a negative line. So what have we done? We have done the middle of lines, the middle, and the tilt. Last thing is we are doing the length of a line, the length, which is the distance equation. The distance formula is giant square root x minus x parentheses squared plus y minus y parentheses squared. We're going to say this and write it at the same time. So try to coordinate with me. Okay, ready? We're going to say it. Distance is a giant square root, subtract the x's squared plus subtract the y's squared. Distance is giant square root, subtract the x's squared plus subtract the y's squared. Distance is giant square root, subtract the x's squared plus subtract the y's squared. Distance is giant square root, subtract the x's squared plus subtract the y's squared. That's the distance equation. Here's your distance template. Distance equals, your template is minus squared plus minus squared. That's called a template, which is your equation, but take away the x's and the y's. Now we circle the x's. Once again, it does not matter whether or not you go -5 minus 1 or 1 minus -5. It doesn't matter how you start, left to right, right to left. What does matter is whatever direction you started with, you finish with. I personally will always go left to right. So -5 minus 1, 3 minus -5. Now you start doing the math. Careful not to drop that square root sign. And the distance is 10 units. I don't think I tell you what the units are. Now, if when you do the square root, it's not a perfect square, I expect you, okay, to factor and simplify and also give the decimal version. I want both every single time. Do this page distance equation on your own. Pause the video. Okay, welcome back. If you're just checking your answers, you can speed up at this point just a bit. Hopefully you did a template first. So you end up with a 4 and a 9. Of course, you bring that together. That's root 13. You can't simplify it, so you are done. To find that distance, you should have had a template. Y minus y. Positive 1 minus negative 1. X minus x. Double negative makes a positive, so this is 2 squared. Negative 3, that's plus 5. That's going to be 2 squared. 4. Square root of 8. When you simplify, 2's come out. You end up with 2 root 2 is your distance. Remember what we've done today? We have found the middle of a segment, we have found the tilt of a segment, and we have found the length of a segment. And we have learned the equations for midpoint, slope. This page was midpoint. This page was slope, and then distance. Make sure you take 1 minute to summarize the 3 main concepts from today's lesson.